The next operation we need to work with polynomials is division, and there will be two techniques that we're going to be using to do our division. And the technique that you use is going to be dependent upon what you're dividing by, not so much what you're dividing, but what you're dividing by. When you divide by a monomial, what you're going to do is break the fraction into several smaller parts and do smaller division problems one fraction at a time. If you're dividing by anything larger than a monomial, binomial, trinomial, etc., you'll have no choice but to do long division. Let's look at several examples of each of these techniques. Start off with something fairly simple. Let's take a 4x plus 10 and divide it by 2. 2 is a constant and therefore does fall into the category monomial. Now what I mean when I say take the problem and break it up into several small fractions, I'm going to take the 4x and the plus 10, and instead of writing the whole thing over 2, I'm going to write them separately over 2. What I can do now is do two smaller, simpler divisions. 4 divided by 2 is 2, so this is a 2x. 10 divided by 2 is 5, so my result comes out 2x plus 5. Pretty simple concept, so let's try that again. Let's take a negative 9y plus 12 and divide by a negative 3. Again, I will break this up into a negative 9y plus 12, not all over negative 3, but separately over negative 3. And then I divide. Negative 9 divided by negative 3 is positive 3, and 12 divided by negative 3 is a minus 4. Now both of these problems have come out very nicely because the division was possible for both fractions. Let's look at a situation where perhaps it's not possible. Let's look at 3x squared minus 4x plus 8, all divided by 2. This one will be broken up into three small fractions. A 3x squared minus 4x plus 8, and then once, twice, 3 times divided by 2. Now you'll notice in the very first fraction here, 2 doesn't divide into 3, and that doesn't reduce in any way whatsoever. So in this type of problem, you'll just leave your answer like that. Come on to the next one. 4x over 2 is a 2x. That can be divided, so I'll do it. 8 over 2 is a 4, so that's what my answer is going to look like. Now let's try it again, and let's put some variables in the bottom this time. Let's look at a negative 15m cubed minus 6m squared plus 15 over negative 5m cubed. Again, breaking it up. And dividing each one by the original denominator. You just have to be content with this type of problem to do whatever division you are able to do. And leave behind whatever you can't. Negative 15 over negative 5 is a positive 3. M cubed over m cubed cancels perfectly. Alright, negative over negative makes a plus, but 6 over 5 does not reduce. Now here where we're going to have to be a little bit more careful. I've got 2 m's on top, 3 on the bottom, a square on top, a cube on the bottom. When things cancel, you only have 1 m left, and it has to be left on the bottom because that's where there were more to begin with. A plus and a minus will make a minus. 15 over 5 make a 3. There are no m's to be canceled, so all 3 are left, and they were left on the bottom because that is exactly where they started. Alright, Let's try one more of this type before we move on to the next type. Let's take negative 12 x to the fourth plus 6x squared minus 15x plus 4. We're going to divide by a negative 3x squared. Going to break it up again, just like I've done with all the rest. With each part of the numerator sitting one at a time over the denominator. And I go doing my division. Negative 12 divided by 3 is a 4. X to the fourth over x squared is an x squared. Next, positive 6 over negative 3 is a minus 2. X squared over x squared cancels completely. Negative over negative makes plus. 15 over 3 makes 5. X on top, x squared on the bottom. When you cancel, there's one x left on the bottom. Minus and plus right here make a minus. 4 over 3 can't reduce. And there's an x squared left on the bottom because there was nothing there to do any canceling. So here are a few examples when you're dividing by a monomial. Now let's see what happens when you divide by a binomial. When you divide by a binomial, you have to do a long division type problem. In other words, if I had a 2x squared minus 9x minus 18 divided by x minus 6, I'm going to have to step over here to the side and set it up as a long division problem. The x minus 6 goes outside. The 2x squared minus 9x minus 18 goes inside. What I always need to focus on when I'm deciding what to put up top here as my quotient is how many times does this go into that. In other words, first term with first term always tells me how to divide. X times what gives you 2x squared? Well, it'll be a 2x. And notice the x terms will line up with the x's. Constants will line up with constants here in just a second. 2x times x is the 2x squared. 2x times minus 6 is a minus 12x. Now at this point, normally in a long division problem, it would be time to subtract. But instead of subtracting, I prefer just to add opposites so I don't make any sign errors. In other words, I'll take this positive 2 and turn it into a minus 2. I'll take this minus 12 and turn it into a plus 12. And again, my only reason for doing that is that allows me to add instead of subtract, which I think is easier. These two terms cancel, and they always have to. The negative 9x and 12x is a 3x. So I've finished with that part. Now, in a typical division problem, it'd be time to bring down the next digit. I just bring down the next term. Again, 3x and x is what we're paying attention to. X times what gives you 3x? Well, it would be a 3. 3 times x is the 3x. 3 times minus 6 is a minus 18. And again, I'm changing my signs. This 3x becomes a minus 3x. This minus becomes a plus. That allows me to add, and I've got no remainder. So my answer, or the quotient, is just a 2x plus 3. Now let's look at least a couple more of those. Let's take a 2x squared plus a 7x minus 18 and divide it by a 2x minus 3. Again, setting it up as a long division problem. The 2x minus 3 goes out here. The 2x squared plus 7x minus 18 goes in here. Paying attention, nothing but the first term. And the first term, 2x times what gives you 2x squared? Well, a plain x. I distribute. This becomes 2x squared when I multiply, and a minus 3x when I multiply again. Changing signs, I add. That cancels, and I get a 10x. Like before, I drop down the next term, and I start again. 2x times what gives you a 10x. Paying attention to first term and first term, it would be a plus 5. 5 times 2x is a 10x. 5 times a minus 3 is a minus 18. Change the signs. Add, and again, no remainder. There's your quotient. Now what we really need to see is what happens when we get a remainder and how we write that. So let's go on to see that. Let's take 6x squared minus 5x plus 5 and divide it by a 2x plus 3. Again, setting up it as a long division because I've got a binomial in the bottom. We start dividing 2x and 6x squared. Well, it takes a 3x to multiply by 2x to get 6x squared. 3x times 3 is a plus a 9x. Again, changing signs. This becomes minus. This becomes minus. That cancels. Minus 9 and a minus 5 is a minus 14x. Drop down the next term. 2x times what gives you a minus 14x? Well, it would be a minus 7. Negative 7 times a 2x is the negative 14x. Negative 7 times a plus 3 is a minus 21. Again, changing signs. This becomes plus. This becomes plus. When I add, that cancels. When I add, that becomes a 26. So I have a remainder. Since 2x can't be multiplied by anything to get a mere 26, I do have a remainder. So my answer would be written as 3x minus 7. That's the quotient part. And as you've always done with remainders, you write the remainder as a fraction over the original number that you were dividing by. And this time the original divisor was that binomial. So we use that in the denominator of the fraction that is our answer. Let's try another problem. Let's look at w cubed minus 8 quantity divided by a w plus 3. Now when you set this one up, one more thing you have to watch out for. Of course, the w plus 3 goes out there. But since I have a cubed term here, I have to always write what I'm putting underneath here in descending order. So w cubed comes first, but there's no w square to fill in this place, to be a placeholder. So I have to write in a 0w square, just to hold that place. There's no w, so I have to write in a 0w. There is a constant, so I'll go ahead and put it in. And again, if you start off with the third power, something has to represent second, and then first, and then constant. Alright? Didn't put any zeros in up here because I only started with the second power, and I had a first, and I had a constant. So it's just the missing powers and the missing terms that have to be accounted for in this way. Alright, so let's start multiplying. W times what gives you w cubed, w squared. Multiplying, w cubed plus 3w squared. Change the signs so that I can add. That cancels, and I get a negative 3w squared. Drop down the next term. And again, if I hadn't put that there, I wouldn't know what to drop down right now. What do I multiply by? Minus 3w. Multiplying, minus 3w squared minus 9w. Change the signs. Add. Bring down the next term. W times what gives you 9w? Plus 9. 9w plus 27. Change the signs. Cancels. And this is a negative 35. Again, a remainder. So your answer is w squared minus 3w plus 9 plus, and again, your remainder is written as a fraction over whatever it was you were dividing by. Alright, let's look at one more example like that, and you'll be ready to long divide all by yourself. And perhaps we should see another example with a term missing. Let's look at 9x cubed minus x plus 3 divided by a 3x minus 2. When I write it out, 3x minus 2 goes out here, and here I have to have a 9x cubed. Now stop and think for a second what's missing. You've got cubes, you don't have what? You don't have any x squares, so you have to put it in. You do have x's, so that's okay, and you've got the constant. The constant was missing, I'd have to put a 0 there too, but I have one. Let's multiply. 3x times what gives you 9x squared? 9x cubed. Another 3x squared. Multiplying, I get my 9x cubed minus 6x squared. Change the signs. Add. 6x squared comes down. And again, drop down the next term only. 3x times what gives you 6x squared? Well, a 2x will do it. 6x squared. 2x times 2 is a minus 4x. Again, change the signs. Add. You get a 3x. Drop down the next term. 3x times what is 3x? It would be a 1. So you'd have a 3x minus 2 when you multiply. Change the signs. Add. This time you had a remainder of 5. So you'd write your answer as 3x squared plus a 2x plus 1 plus the remainder of 5, always divided by the original denominator.